Welcome to Monday Morning Coffee with Inside the Firm. Each week, our hosts will be interviewing local, regional, and national business leaders to give you an inside peek into how they lead their business to success in the ever-competitive business climate.
Welcome to another episode of Inside the Firm. We have a special edition here. We're at the AIA convention again at the RCAT booth. I'm Alex Gore, your host. I'm here with Greg Fantin. He's a vice president of marketing, or maybe they're just the vice president?
Vice President Marketing. I'm marketing and sales focused both.
Yep. For Rmax, which is a division of Sika, which is a huge corporation. I just talked to all the ladies and gentlemen over there. Rmax specifically has been manufacturing Polyiso for commercial and residential walls, roofs, and specialty applications for over 40 years. In addition to this role at Rmax, Greg sits on the board of directors for PIMA. All of you probably know what PIMA is. For the few that don't, it's Polyiso Insulation Manufacturers Association, and recently completed a 3-year term as its chairman from 2019 to 2021. Greg, welcome to the show.
Thanks a lot, Alex. I'm happy to be here.
Yeah, one thing I didn't mention before, it's about 20 minutes, plus or minus. So we'll go from there. PIMA. So I made a joke about it because I bet you no one knows.
Nobody knows. I was going to say, dinner conversation. When I'm at parties, people don't ask.
They
Tell
never
me
bring
about
that.
PIMA. No,
Yeah.
They don't do that.
But here, tell us about PIMA. Is it more just the organization? Because if you're new to the industry, architecture, there are so many groups. Like there's insulation just for the ICF, association that has their own meetings. What is PIMA? What do they do? What did you do there?
Okay. Well, that's a good question. PIMA was formed about 40 years ago when polyiso cyanurate, as it's specifically called, became a product for insulating roofs primarily. And the reason the organization formed 40 years ago is there were, at the time, blowing agents and certain chemicals in polyiso that were considered problematic. And so the manufacturers of polyiso formed together to figure out how can they work with the government. So they formed a trade association to try to work with the government, the Environmental Protection Agency, to make the product safer, new blowing agents and these sorts of things. So PIMA was originally formed to make the product environmentally friendly, and then subsequent to that, the organization focused on building codes, specifically roofing codes, to try to make roofing more energy efficient. And now, over the last 10 years, PIMA has been very focused on wall insulation as well, because building codes on the commercial side have always focused mostly on roof insulation, R30s, trying to make the roof as energy efficient as possible. But if you think about a building like a cooler, like a Yeti cooler, if you had a really well insulated lid, but you just put that lid on a wooden box, it would be a horrible cooler, right?
Yeah, or glass.
That's right. So buildings now, commercial buildings, are being, the building codes are requiring continuous insulation around the exterior of the building. Like on a steel stud building, you have to put continuous insulation along the outside of the studs, rather than traditional manufacturing where you might put gypsum board over the studs and then just fill the cavity with fiberglass or something else. Now, codes are requiring you have to create a cooler-like building where you have continuous insulation on the outside. And polyiso works great for that.
And going back in history, was part of the problem people would order polyiso, and some of it would show up and be polyiso and awesome, and some of it would be filled with nonsense, sand, or just a little. Was that part of the problem?
I don't know about that being part of the problem, but you make a very good point. Part of the trade association as well was to have some product standards attached, because you're right, when you have a new product created, 40 years ago it would have been a new product, and you want some consistency so that if architects are specifying it or contractors are purchasing it, it's going to be, they know that it's going to meet a certain level of standard. So we have within PIMA, the trade association, there's a program called Quality Mark for roofing materials, where the material has to meet a certain R value, or LTTR, which stands for long-term thermal resistance. So there's an R value number attached to polyiso that manufacturers are supposed to meet, and then architects know how much of it to specify in a roof to meet the R value requirement in the roof, and the walls work the same way.
Yep. One of the most interesting developments in the code that I really like pertains to residential construction and exactly the industry that you're in. Have you heard of the perfect wall system?
Yes.
So obviously they came about, and one of the problems within the code that used to be is, well, you still have to have this high R value, and you have to basically break it up between in-wall and out-of-wall. The 2021 code, if I'm not mistaken, now allows for just, you have to do a higher R value, but you can just do continuous on the outside.
Correct, yeah.
Which is great. I really love that system. You kind of want to explain?
Alex, I think this is hilarious. Well, hilarious is a subjective term, but
Yeah.
I think it's really coincidental. You mentioned the perfect wall and using 100% exterior. We didn't have a pre-discussion about this. I was going to bring it up,
Yeah.
and you just happened to bring it up because I was going to say that when you put enough exterior insulation on the outside of the studs, or whether it be residential or commercial, that perfect wall concept works in commercial construction as well as residential construction.
Yeah.
And you can eliminate the need to put any fiberglass or spray or any kind of interior cavity insulation. So when you think about it, it's not just better from an R value thermal resistance standpoint, because again, the continuous insulation prevents the thermal bridging through the studs, right?
Right.
That's really what you're trying to get at with the perfect wall. You also control your dew point completely. You keep it, you keep any moisture from getting on the inside of that wall. It is the perfect wall, so I'm really happy you brought it up, but it doesn't just apply to residential construction.
Yep. And one thing that's interesting too, I think the code still has some adaptation to do, because putting it all on the outside, I love that they allow for that. There is a semi-problem, and some of the architects at my office was bringing this up. You mentioned the dew point. If you have so much insulation on one side versus the other side of the wall, that dew point can be a problem where that dew point then hits, and it could hit kind of in your wall and where you put your vapor barrier and all that. And we even talked to the building code officials about that. And they said, this is when you get too bureaucratic and work with the government, sometimes they're kind of slow to respond, but they're like, yeah, that is an issue, but that's just the way it is right now.
Right.
So I like where you can to put it all on the other
now,
side.
Alex, you raise a great point about dew point. A great point about the perfect wall. And regarding trade associations, we're involved with PIMA, our company is, but we're also involved with the Foam Sheathing Committee, which is made up of manufacturers of other plastic insulation. It might Polyiso, extruded polystyrene. We have on the continuousinsulation.org website a wall calculator where you can put your various materials of how you're going to construct the wall, whatever kind of substrate you have, whatever kind of cladding you have, whatever kind of continuous insulation. So if you want to use extruded polystyrene, if you want to use polyiso, if you want to use mineral wool, you can build that wall on that wall calculator, and it'll tell you what your effective R value is, what your U value is. It'll also tell you where the dew point would fall.
What's that website again?
Continuousinsulation.org.
Okay. And then you mentioned, did you say rock wall?
Mineral wool.
Are people putting that on the outside or on the, is there a product?
There are products that in mineral wool can be used. Rigid mineral wool board can be used for exterior continuous insulation. It's a lower R value. You generally get about an R4 per inch.
Okay.
So, and now, some people might say I'm biased as a polyiso manufacturer because polyiso gets a higher thermal performance than mineral wool does. I think the challenge with mineral wool on an exterior application is also moisture. Mineral wool will absorb moisture. It will dry out, but once it does dry out and then gets re-wetted, then there are issues potentially with the fibers and keeping that material consistent.
And I agree, and that's why I kind of question. I would put that on the inside. I actually think it's a good product. On the outside, I'd be a little bit nervous.
I agree.
Could you talk about the different polys? Is that within your...
Yeah, are you talking about the different polystyrenes versus polyiso?
Yeah. What's the difference? Why would you choose one over the other?
That's a great question. As a polyiso manufacturer, most architects are very familiar with it as a roofing product.
Yeah.
It has high thermal performance and it has great fire resistive properties. The reason why it's become probably 80% of commercial roofs are comprised of polyiso insulation, flat roofs, the low slope.
Yep.
Because you can eliminate unnecessary materials. You don't need to use a gypsum board barrier. Most times when you're gonna assemble a roof, you're gonna put a vapor barrier down. You're gonna put gypsum board as a fire stop if you use extruded polystyrene. But if you use polyiso, because of the fire resistive properties, you don't need the gyp. And so it gets higher R value than extruded polystyrene. Extruded's about a 5 R per inch, and polyiso is 6 to 6.5 per inch.
That's awesome.
Now, the other thing I would say is so comparing on wall product, it's the same principle as the roof. Thermal polyiso gets a 6 to 6.5 per inch. Extruded polystyrene gets 5 per inch. Expanded polystyrene gets 4 per inch. Expanded polystyrene is a product you primarily see in EIFS systems, if you're familiar with an EIFS, which is exterior insulated finishing system. Yeah. It's like a stucco-like material. It looks like that on the outside. EIFS uses expanded polystyrene because it's easy to rasp. You can create a very flat so that the EIFS material can apply to it easier. But that's the main reason it's used. As EIFS, as building codes get stricter, like higher R value requirements on walls, similar to what happened with roof, we're expecting that EIFS is likely going to incorporate polyiso more and more into an EIFS and maybe use a very thin layer of expanded polystyrene over polyiso so you can rasp it. And then you would have sort of a composite wall if you want to do an EIFS design. But so if you look at the 3 types of polys, as you call them, expanded polystyrene is generally a 4R4 per inch. Extruded polystyrene is 5R per inch. Polyiso is 6 to 6.5 per inch. Now you might ask, why is it not consistent, 6 to 6.5? That the difference is polyiso is a faced material. There are facers that are on. So the thinner the product is, if you're looking at a 1/2 inch of polyiso, there's a facer that makes up part of that material. That doesn't really have an R value attached to the facer. So as you get thicker, more foam is accounting for the board, less facer material. So you actually get a higher R per inch the thicker you go with polyiso.
That makes sense.
Yeah, like a 2-inch polyiso board is actually 13.2 R. Whereas a 2-inch XPS board is R10.
I'm trying to remember what the actual code is for residential, because 2 inches is doable. The only problem I see with when you're doing
most residential, you'll find R5 for exterior, and that's a 3/4 inch polyiso board or a 1-inch extruded.
And I'm just thinking if you're putting all of it on the outside.
Oh, all of it on the outside. Then you're going to want to go thicker.
Yep. And then it just gets, you have to do sleepers, and then you have to nail through screws through or all
correct.
that.
So if you think about an extruded polystyrene, to get an R10, the same thickness will give you an R13.2 with polyiso.
And one thing about the perfect wall system too is that you can do, if you want to, depending if you want to eliminate systems, is you can eliminate the insulation in the interior. You can eliminate drywall in some places, which makes so our firm does construction too. And with the problems in the world, one of the big things is just coordinating to get everything at the right place at the right time with the right people that can do it, right? And one of the best ways to reduce costs is eliminate doing things.
Oh, hey, Alex, I'll tell you what. On a polyiso wall, now we could talk residential or commercial, but I'll stay with commercial for a moment. Probably a lot of this audience is probably commercial architects. On a steel stud wall, because of the thermal properties and fire properties of polyiso, you can create an NFPA 285 wall with just the polyiso board on the exterior of the studs. You don't need exterior gyp, and you don't need a spray applied air barrier. The polyiso, because of the foil facer, if you use a foil face polyiso product and you tape and flash the seams, treat the joints, you can create that perfect wall where you eliminate gypsum, you eliminate exterior spray applied chemicals on that gypsum, and you put your polyiso board straight against the steel studs. Now, you mentioned reducing material and labor costs. The other thing it does is reduces environmental impact significantly. When you think about building materials, most people think about how recyclable is it, or what chemicals are is the material comprised of. But we often don't think about the environmental benefits of not having to produce,
not doing it.
Yeah. Think about, like, we've done some analysis where we've looked at the amount of physical spray on a 40,000 square foot building. Like, if you were going to take because we're talking about petrochemicals here.
Yeah.
These are all oil-based derivatives, the spray applied air and water barriers.
Yeah.
If you spray 40,000 square feet of a wall at an average mil thickness,
Yeah.
that's the same amount of chemical that it would take to make over 1 million plastic shopping bags. When you imagine how much of that material you don't have to pull out of the ground, you don't have to refine it, it doesn't have to end up on that wall. Same with gypsum. A 40,000 square foot building is going to have, of coverage, is going to have about 100,000 pounds of gypsum board. It never has to be made.
Yep.
So you've got a wall that's probably 35% cheaper to construct, meets all of the fire code, the NFPA 285 fire codes, and like you said, the perfect wall. If you don't want to put interior insulation in the cavity, you don't need to, as long as you use a thick enough exterior.
Yeah.
But if you want to put something in the cavity, that's fine. And you mentioned mineral wool. We talked about mineral wool earlier. Mineral wool bats, I find them pretty effective for sound attenuation. So
that's why I like them.
Yeah, if you want to add a little bit of extra insulation and you want it to be a mineral wool, put it on the inside and it helps with the sound.
Yep, absolutely. So we talked about the roof and the walls. How about underground?
Yes, I'm very glad. I was going to bring it up if you didn't. It's so funny that we are having this conversation because I didn't know you were going to ask me this stuff. Yeah. But yeah, so Polyiso is a great product to use below grade, both on the exterior basement wall as well as below the foundation slab. Now, what's funny about this, and I say funny, again, relative subjective term, but for 40 years, most people's perception of Polyiso is that it absorbs too much water, too much moisture to be used below grade. It's not true. The perception of Polyiso absorbing water has to do with the roofing, the facer that is used for Polyiso roofing products. You got to remember, 90% of Polyiso historically has been used in roofs.
Yep.
And the roofing Polyiso facer, it's a water absorbent, organic paper-faced, it's a very inexpensive facer product because it's going to go under a roofing membrane.
Yep.
It's going to go over a vapor barrier. You don't have to worry about moisture. So when people think about a traditional piece of Polyiso, if you drop that in water, it will absorb. That paper facer is very absorbent.
Yeah.
But you would never use that below grade. You would use a foil face, you would use some other type, you might even use a coated fiberglass face product, but mostly foil. You put that below grade, it has the same water absorption rate as extruded polystyrene does, which is the common product used there.
So it's all about the facer that people were misapplying in the wrong.
It's all about the facer because extruded polystyrene is an unfaced product. It's very consistent that way. Yep. Polyiso is different because it's laminated to facers, so you really need to make sure you have the right facer for the right application you're using.
Yep.
And that's why our company, Rmax, is aggressively now pushing Polyiso below grade. Because when you think about it, if you're going to use 2 inches of extruded polystyrene to get an R10 below grade, you only need 1.5 inches of Polyiso.
Yeah.
Again, less chemicals, more efficient. It's a more environmentally friendly product.
Yeah, absolutely. Well, I mean, this has been great. Very helpful, very informative is the word that I was looking for. Anywhere you want to lead or point our guests to if they want to look up more or just kind of dive back into it?
Okay, I'm a little bit biased, so I would say go to rmax.com.
Yeah, of course.
rmax.com. In fact, we do also have a link to that wall calculator directly on our site. The continuousinsulation.org website is a good one for continuous insulation information overall. I would say the PIMA website, pima.org, is a good place to go. You just want to make sure that because Polyiso is a flexible product, you want to make sure that you're using the right facer, that you're using the right compressive strength, because again, Polyiso can be made to order based on if you need a 25 PSI or a 20 PSI.
Is that mainly pertinent on the roof or on the walls too?
It really depends. It's to be honest with you, the compressive strength of the product is fine. If you were to use a 16 psi product, it would meet whatever you really need it to meet. But people sometimes want extra.
Engineers
are thinking about maxing it out.
Yeah.
And so a lot of times they'll think if somebody's going to be walking on a roof, they'll want a certain they'll want a much more a stronger, so that the roof you don't break the ISO on the roof. I don't see that. I don't find that an issue. Because if you really think about pounds per square inch and you measure it out, you're going to be just fine with an R16. I mean, not R. I mean, with a 16 psi or a 20 psi. But the product can be made much thicker. And in fact, the other thing I would mention is for roofs now, the industry's making high density ISO boards that can be on a re-roof. You can add those just like just like a layer of gypsum board that has a higher R value.
Can it get so much? Are you removing the? It's not called a backer board. What's it called? But basically the board that spreads out the load, or do you still need that in the system?
Well, are you talking about on a roof or in a wall?
Roof.
On a roof, generally, if it's a metal deck or it's a concrete deck, you can usually just lay the ISO down over your vapor barrier and then put the membrane over that.
Yep. Good. Well, perfect. Well, thanks a lot, Greg. I really enjoyed this conversation. Thanks for stopping by.
Alex, it's been my pleasure. Thanks a lot.
Awesome.